Greetings everyone, welcome to Side A, Side B. In this video, prove the CPCTC Theorem of geometry. The overall plan, develop a line of thought supported by axioms, definitions, postulates, and theorems. So what's in our toolbox? How about straight up algebra and geometry? For the interest of clarification, CPCTC is short form for corresponding parts of congruent triangles are congruent. Take it how it sounds. The usefulness of this theorem: prove unknown parts of triangles are congruent by first proving the triangles are congruent with the knowns. On that note, first, we need to prove a theorem to support our proof of the said theorem. Well, all right. The activity to prove operations that we took for granted continues. We want to prove the right angle congruence theorem. Suppose we are given angle A and angle B are right angles. Prove angle A is congruent with angle B. In a classic geometry proof, we have our statements and reasons. The first statement: angle A and angle B are right angles. The reason? This was given. Next, if we take a K measure to both angles, we find both angles are 90 degrees. The reason? By the definition of right angles. Which means K angle A equals K angle B. Reason? If A equals C and B equals C, then by the transitive property, A must equal B. Finally, angle A is congruent with angle B. The reason? The definition of equality of angles. Since the white boxes match, we are done. Still though, even if we've proved two triangles are congruent, the unknowns are still unknown. As it were, proving the unknowns are congruent without knowing them. Let's begin. Welcome back. Suppose we are given line AQ is perpendicular with line BC, and line AQ bisects angle BAC. Then prove triangle BAQ is congruent with triangle CAQ, and then we'll prove the said theorem. Again, we use a classic geometry proof. The first statement: line AQ is perpendicular with line BC, and line AQ bisects angle BAC. The reason? This was given. Next, angle BQA and angle CQA are right angles. Reason? The definition of perpendicular. The third statement: angle BQA is congruent with angle CQA. The reason? By the right angle congruence theorem, which we proved, circled in yellow. Nice. Folks, we have the following statement: angle BAQ is congruent with angle CAQ. For what reason? The definition of an angle bisector, which is a line that divides an angle into two equal angles. Basically, the line cuts an angle exactly in half. We mark the congruent angles with blue in the yellow circle, and it's something we don't need to prove. The next statement: line AQ is congruent to line AQ. For what reason? By the reflexive property or axiom. The axiom states that any geometric object, such as a line segment, is congruent or equal to itself. Sounds good? Circled in yellow. We're almost done. we have triangle BAQ is congruent with triangle CAQ. By the statements and reasons of 3, 4, and 5, the reason we can refer to the angle-side-angle postulate upon proving two triangles are congruent. Lastly, we mark all the sides and angles of each triangle as being congruent as follows in the blue, and then make a list of them. The reason, by the following definition, two triangles are considered congruent if they have exactly the same size and shape, meaning all of their corresponding sides and angles are equal in measure. Put differently, if we could pick up triangle BAQ, we could place it on top of triangle CAQ in such a way they would coincide with each other. Hence, the CPCTC Theorem is shown to be true. Very nice. To conclude, this theorem could be useful in proving the unknown parts of triangles are congruent, or knowing them without knowing them. On that note, until next video, ladies and gentlemen, knowing an exit without knowing an exit is still an exit.